let's get going. Two things I want to talk about first. The order of operations. The order of operations is just that. It used to be called the hierarchy of math. The hierarchy is just another way of saying levels, ranking. King, queen, prince, princess, duke, duchess. That's the hierarchy. President, vice president, speaker of the house. So this is the way it should be done. The first thing you have to do are any special operations. What do I mean by special operations? Brackets, brackets, parentheses, exponents, absolute values, radicals, square roots, nth roots. These are called factorials. If you ever take a statistics course, a factorial is a counting technique. All it means is whatever n is, whatever number you give me, say 3. 3 factorial is you start off at this number and multiply everything down to 1. So 3 times 2 times 1 is 6. Is that clear or is it fuzzy? Is it a little bit fuzzy? Let me see here. Is that better? I should have some eye doctor business cards here. If this is fuzzy, go see this eye doctor. In calculus, we deal with integrals, double integrals, triple integrals, linear integrals. There are over 400 symbols that we use, 400 special operations that we use in mathematics. Those have to be done first. Once you get those taken care of, then what do you think the next most important stuff is? Multiplication and division. Once you get all those taken care of, then addition, subtraction. You notice how it goes from the most difficult to the most simple. And that's what mathematics is about, is taking whatever problem you have, do the hard stuff first. And then when you're finally left, your last step should be the easiest part, adding and subtracting. So far so good? Now, mathematics is not a math is not a course in itself. Mathematics is a philosophy of logic. Because what do you solve what are you faced with in everyday life? What do you call the issues you're faced with? Starts with a P. Problems. What do you do for homework in math? What do you solve there? Problems. You think that the same word is not used in both of those for a reason? They are, because the way you solve them, you use the same logic. In real life, you're faced with a problem. You take what you know, what you have, and apply it to solve that problem. To fix a a hole in your house. You don't start painting it, do you? That's the easy part. What do you have to do first? Well, you have to cut it out, make square, put the new one in there, mud it. You start with the hard stuff first, getting it ready, and then do the easy stuff at the very end. That's the order of operations. You can't fix something unless you do it in a specific order. Because mathematics is a philosophy of logic, you read left to right. You read left to right. How would you read that? Yeah, 6 divided by 2 times 3. You can write each one of those words down. So mathematics really is all words. Because it is a language. Mathematics is a language of its own. The faster you learn the words we use in math. This symbol means division. This symbol means multiplication. Are there any other words we can use for those symbols? Is multiply times product. Each one of those mean the same thing. Again, it is a language. The sooner you learn the language, the words of the language, the easier math is. Go ahead and work this out. Work this out. And tell me what your answer is. Okay, we have not. Anybody have anything different? Anybody get 1 as an answer? Oh, these are 2 possible answers. 2 times 3 is what? Why? You go from left to right first, right? But if you didn't know that, if I didn't put this here, did you know that? Which is why I have the remind test to go through these kind of things. There are 2 ways you can do this. Some people will do multiplication first. Those people. Parentheses, exponents, multiplication, division, addition, subtraction. Americans learn it that way. Europeans.
Is that when they solve the problem when it's inside the parentheses?
We'll get that, yeah. In Europe, they use bedmass. Brackets, exponents, division, multiplication, addition, subtraction. But again, brackets, exponents, parentheses, exponents. I just showed you there are many more than just those 2 things. That's why I don't like this. People who, once you get away from math for a while, let's say when you get married, you have kids and they go to school and they'll ask you, can you help me with this algebra problem? And you'll put down PEMDAS and you said, okay, let's do multiplication. You'll memorize it this way. So you'll see, let's do parentheses first, then exponents, then multiplication, division, addition. This is how it's memorized. That's why I try to tell everybody, keep away from those, both of those. Learn it this way first. Special operations first, multiplication, division. They're both in the same level. They're the same level of importance. They're actually inverses of each other. They're opposites of each other. Addition, subtraction, they're opposites of each other. So they're the same level of importance. All right, so that's the first part, the order of operations. Now, the properties of math or algebra. Can anybody guess where algebra came from? What country?
Greek.
No, a lot of people think Greek. No, the Greeks came up with geometry. It is Iraq. It's this Middle East.
It's an Arabic word.
It is very good.
Arabic, like you say to guys.
Yeah,
Jabber.
algebra. Yeah, al means from. Yes, because the first mathematician, because it happened all in the market. Commerce. If I had 3 pigs and you had 5 geese, how do we know what's a fair deal? You can't. I wouldn't say 1 for 1 is a fair deal. So we'd have to have some sort of numeric system saying, okay, 2 geese equal 1 pig. So now we can start discussing, debating what's fair. And then that was bartering system. Then came money. Which was the worst thing that could happen to humans. Because once you have money, now you have greed. When it was a barter system, everybody had just what they needed. Money came in, now everybody wanted more money. And more money. So things stopped. But it all came from the Middle East. So the properties of algebra. These are important because they tell us what and how to do things. The first one. The commutative property of. The commutative property of. What does to commute mean? Not communicate, close. Well, it has the same as communicate as a, but
It comes from commute.
it comes from exactly. It comes from the word commute. What does to commute mean?
Travel.
To travel, to move from one place to another. So it's move. So it has to do with travel. Very good. Because we have the word of and the colon, we have a list of them. The commutative property of addition. Remember, to move things. What this one says is x plus y is equal to y plus x. Is that a true statement? Okay, this is where a lot of people get derailed when it comes to math. We're in a math course and we see letters. Now, what this means is once I define, these are called variables. Once I define a variable, it stays that way until I redefine it. So let's say I'm saying that x is 3 and y is 4. So that means 3 plus 4 is 7. 4 plus 3 is 7. So it doesn't matter how I arrange it. I can move it around. The second property, commutative property, is of multiplication. xy is the same thing as yx. Now we have to go on to another side discussion. What's missing between those letters? A symbol, a math symbol. We had the symbol for plus between these two letters, but there's nothing there. Well, multiplication is the only operation that doesn't have to be there to be there. For addition, subtraction, and division, it has to be there to be that symbol. Does that mean anything? No. Once I put another number behind it, now it means something. Same thing with this one. You have to have, that's okay. These are called what are called binary operators. These are called binary operators. Binary simply means two numbers. You have to have one in front of it, and you have to have one behind it. Throughout this course, I'm going to use which binary operator will work, which one won't. This one, I'm just simply saying add, subtract, multiply, divide. Multiplication, I can either write it this way, I can write it this way, I can write it that way, or I can write it this way. Yes, it's there. This one, there's nothing there, but it's implied it's there. This one's there, it's a dot. It doesn't have, so multiplication is the only one that doesn't have to be there to be there. So if I gave you this, how would you read that? 3 times x. Very good. Yes, you'd read it 3x. We're going to say that in this class as 3x or 4y or whatever, but it means 3 times x. So 3 times 4 is the same thing as 4 times 3. They both equal 12. So that's the commutative property. That's the property of allows us to move things around. Are we limited to only 2 numbers? No. Let's see what symbols that I use there. No, it's 2. The next property is the associative property of. Association, when we associate with our, what we're doing is we're forming a group. When you associate with your friends, you formed a group. You are a group of friends. The associative property of addition. X plus y plus z equals x plus y plus z. You notice in my z's, I'll put a line through it to separate it from my number 2's. Same thing with my 7's. I'll have a line through it. So, and because no, it's Europeans and actually it's most of the countries. America's the only one that doesn't really force it, because in Europe this is a number 1. Well, it looks like a 7. So, but if we put a line through it, we know it's a 7. What are these? Is that a 0 or a letter O? Is that? That's an O, that's a 0. A lot of times you'll see me when I have my zeros, I'll put lines through them. Engineers, programmers, we always do that. Actually, I should have told you my background. My bachelor's in mathematics, my bachelor's and master's degrees are in computer engineering and mathematics. My doctorate's is in mathematics, computer engineering, education technology, and it focuses on education technology, so programming and things like that. So that's I do all this sort of stuff. Yes, this is a true statement. X plus y plus z equals x plus y plus z. But here's the problem. Nothing in our known universe can process more than 2 bits of information any one time. What does that mean? If I gave you 3 numbers and I told you to add them, how would you do it? Go left or right. Yeah, you start with the first 2. Or we're going to start in the back. 5 plus 4. So this is where the concept of the parentheses comes in. Remember, order of operations, parentheses. Do that first. So here, now we're told what to do first. 3 plus 4 is 7. 7 plus 5 is 12. 4 plus 5 is 9. 3 plus 9 is 12. So it seems like it's the same thing, but in this next example of multiplication, the associative property of multiplication, it becomes more apparent on when you do mathematics. If you have the choice, if all the operations are the same, you can pick any 2 numbers to put together first. Three times 4 times 5. 3 times 4 times 5. Work that out for me. Both sides. And let's hope you get the same answer. No.
Oh, the other side too.
Doing both sides, yeah. Finish? What'd you get? I won't ask any presenters. Some people may have gotten a different answer. Let's work it out.
One side.
Yeah. If both sides come out the same answer, you did something wrong.
1 came 36, the other 60.
Yes. We're not supposed to, but if you're going to make a mistake, it's probably on the left-hand side.
Did I do my math wrong?
Yes. They have to be equal. So let's look at this. So first off, what is 3 times 4? 12. So now, when you have 12, 12 times 5. 5 times 2 is 10. Carry the 1. 5 times 1 is 5, plus 1 is 6. So it's 60. Yeah, yes. How about the other side?
I didn't do that strategy. I was trying to hurry up.
I'm perfect. You are a perfect person for my presentation, because that's exactly why. Because now, how many of you got 60 on the right hand side?
I did.
So 4 times 5 is,
But on the right side, on the left. Not the right.
you messed up. Yes, you messed up. So now, whenever you have a number ends in 0, all you do is multiply the numbers. 3 times 2 is 6, and put a 0 behind it. What side's easier? The right side. Less mistakes will happen on this side because there's less work to do. All you have to do is multiply 3 times 2 and put a 0 behind it. This one, you have to do carrying and moving things around. This side requires more work. More work you do, the more chance of errors you have. Rule of thumb. The more work you do, the more chance of errors. So what this does is it gives us the opportunity, if all the operations are the same, pick which ones you want to do first. You can choose. We can move them around if we want to by commutativity, and we can group them together I want to by associativity. So far so good? You noticed, up until now, we had to separate addition and multiplication. Now we're going to combine them. The distributive property. Notice there's no word of after the end of this one. The distributive property. If I gave you 3x, what is this number in front? What is that called? No, the variable is a letter. A variable can be any number you want it to be. It starts with a C. Coefficient, very good. The number in front is called a coefficient. I don't care if it's a number in front of a letter or if it's a letter in front of a parenthesis. Whatever's in front is called a coefficient. So, remember I told you we're going to combine the multiplication and addition. There's the addition, and there's the multiplication. Remember, there's nothing between the A and the parenthesis, which means there's what between there? Multiplication. It's multiplied. By the name, distributivity, you distribute. Whatever's out in front, you multiply it to everything inside there. So, A times X is AX.
So it doesn't go like solve the
Well, no, you can't. Because I'll show you. Sometimes you can't. You're right. You're supposed to if you can, but if you can't, then you have to get rid of the parentheses. So, A times X is AX. Is A positive or negative? Positive. So, here's something I want you all to get used to. Treat the signs and the numbers separately. Treat signs and numbers separately. And this will become apparent because the most common mistake occurs because of that symbol. That little symbol there, the negative, the minus sign, ruins more test grades and homework grades than anything else. You'll forget to put it. You'll put it where it doesn't belong. I've had students who had nothing but pluses on the equations. Their final answer was negative because they said it didn't look right. They just put it there. So, the rule is this. If the signs are the same and you're multiplying them, replace it with a positive. You can only have one sign between two numbers. If you have two signs and they're both the same, it becomes a positive. If they're opposite signs, then replace it with a negative. When you're multiplying two numbers and they're opposite signs, it becomes a negative. If they're both the same sign, it becomes a positive. So, a positive times a positive, positive and positive is a positive. So, A times Y becomes A times Y. And that's the distributive property. One thing that it's used for it gets rid of parentheses. We cannot solve an equation if there are parentheses in there. So the distributive property gets rid of parentheses for us. Now, as I said, this is the most powerful property that we'll deal with. in any of your math courses. It has two names. Going this way is called the distributive property. Distributive. How many of you ever took chemistry in high school or in college? In chemistry, equal signs, when equations are balanced, you use that symbol. It's called stoichiometry. For example, H2O is hydrogen, one hydrogen plus two oxygens. In other words, I can go both directions. I can take a water molecule, separate it two elements, or take two elements, combine them, create water. In order for something to be equal, it has to go both directions. So, what do we call it when we go from this way to this way? What do they have in common? No, both of these, what do they have in common? A. They both have an A in common. If we take out the A, what do we have left? X plus Y. That's called factoring. Factoring looks for what equations have in common and removes it so you can combine them. An example. If I give you 2x plus 3x, what is the answer? Yeah. If I had 2 apples, I gave you 3 more apples, you have 5 apples. Okay, now that's a pretty simple way of saying it. In mathematics, you cannot do anything unless there's a rule that says you can do it. So what says we can do that? What says we can combine the 2 and 3 and put 5 in there? Distributive property. What do both of these have in common? They both have an x in common. If we take out the x, what do we have left? 2 plus 3. What is 2 plus 3? So it's the same as saying 5x. That's where it comes from. But we just take a shortcut because we know it's true. We just take a shortcut. Nothing can be done in math without a rule being there. So far, so good? And there are other properties. The unity property of addition and multiplication. The unity property. In other words, unity is, it doesn't change it. X plus what gives me x? Yeah, if we had 3 plus what gives me 3? 0. So, there. If you add a number to another number, it doesn't change it. If you add 0 to another number, it doesn't change it. X times what gives me x? So 3 times what gives me 3? 1. 3 times 1. So in multiplication, if you multiply anything by 1, you don't change it. Okay, the last property we're going to talk about is called the inverse property. Out of all the properties, this next one is going to be the second most important that we're going to use a lot. What does inverse mean? opposite, exactly. In this property, it's the opposite. What we want to do is we want to get rid of a number. So the inverse property of addition. Nope. It's the inverse property, it's the opposite of it. So x plus what equals 0. So 3 plus what would give me 0? Negative 3. So x plus negative x. Because x plus 3 plus negative 3, 3 and negative 3 cancel each other out, you get 0. And the inverse property of multiplication. X times what gives me 1? 3 times what gives me 1? Very good. So what I put in here? Very good. Okay, now, here's the reason why. There's always a reason why. Every number is a rational number. Okay, that's just a fancy math way of saying every number is a fraction. Instead of rational number simply means fraction. Every number is a fraction. Is that a fraction? Yeah. Is that a fraction? Yeah, it's an improper fraction, but it's a fraction. Is that a fraction?
Actually, it's a whole number, it's not right. Could be a fraction.
There's some of you are afraid to say, because I'll ask you why.
No.
What is 4 divided by 1? So every number is divided by 1. Every number is also multiplied by 1. So there's always a 1 in front and below every number. Anything, there's always a 1. Which would now explain this rule. Remember I said opposites. The opposite of addition is just change the sign. So if I had negative 7 plus what gives me 0? Positive 7, right. So the opposite of an addition problem is just change the sign. But it's not called opposite in multiplication. Here it's called the reciprocal, or the flip. In multiplication, the inverse of a multiplication is fractions. The opposite of multiplication is division. Ooh, I should have brought it that way. We said it was opposite, didn't we? The opposite of addition is subtraction. The opposite of multiplication, division. Dang, I should have said it that way. Now I know next time. When I asked you this, you said 1 over 4. What is this made up of? This is 4 over 1. If I take this number and flip it, I get 1 over 4. The 4's cancel. The 1's cancel. That leaves me with 1. Because 4 goes into 4 once, 4 goes into 4 once. 1 goes in 1 once, 1 goes in, so 1 times 1 is 1. 1 times 1 is 1. 1 over 1 is 1. That's how it all works. So what do I put inside here? Yeah. Just take whatever this is and flip it. Do you change the sign? No. Because if the answer... Well, actually, you don't change the sign. Because if you change the sign... If you change the sign, yeah, negative times positive is a negative. The 4's cancel, the 5's cancel, so you have a negative 1. It doesn't equal 1. So the signs have to be the same. So negative times negative is a positive, so that's how you get positive 1. The reciprocal, or the opposites of a multiplication, is just to flip them. Keep the signs the same and just flip the numbers. I said the inverse is the second most powerful property. Can anybody guess why? Here's why. Whenever you're solving problems, requires you to do the opposite to remove any unwanted numbers. Solving problems requires you to do the opposite to get rid of anything. Because remember, whenever you see an equal sign, whenever you see an equal sign, this is called an equation. This by itself, or remember when I had this? Is that an equation? No, there's no equal sign. Equal, there's no equal sign. This is called an expression. So what's the difference between the two? What's the difference between an expression and equation? Equation or expression?
Well, the expression. Well, the equation, I would say, is more like the same.
No. Almost exactly right. It has to do. Okay, the easiest way of thinking about this, there's one word that would be differentiating these two on a problem. This one would simply say simplify. This one would say solve. Expressions can be simplified. 2x plus 3x is 5x. I simplified it. I didn't solve for anything. A solution requires an equal sign. So here we have an equation. we're solving, you always solve for the variable. So what do you have to get rid of? The 3. No, just, you only look at this side. The golden rule applies here. Whatever you do to one side, you do exactly the other side. So we're only looking to get this symbol by itself. So we have to get rid of everything else. So we have to get rid of the plus 3. How to get rid of?
Do the opposite, 5 minus 3.
Yeah, we do the opposite. Opposite of addition is subtraction, so we subtract 3 from both sides. Positive 3, negative 3, we know it becomes 0, so we have x, 5 minus 3 is 2. There is our solution. Same thing here. Is this an equation or an expression? Equation. There's an equal sign. So the only side we have to look at is the left side. Yeah, we'll take a break in a second, yes. So we want to get the x by itself. What do you have to get rid of first? Why do you get rid of the 5 first? Yeah, because we can't touch the x. We can't touch the x, any part of the x, until everything else is gone. Yes, you said perfectly correct. So this is the opposite. Remember, order of operations. The order of operations says do this, right? We go top down. That's the order of ops. Solutions, you go the opposite direction. You first get rid of any pluses and minuses. Here's the x. Anything plus or minus to this number gets removed. So that's a negative 5, so I have to add 5 to both sides. Those cancel. 3 plus 5 is 8. This is 2 times x, right? What's the opposite of times? Divide. So we have to divide by what? We divide by 2. Both sides. 8 divided by 2 is 4. So we got rid of the multiplication division. Yes?
You said you have the order of operations to go from 1 to 3.
Yes.
And it changes when you need to solve?
Yes, because when you're simplifying equations.
Simplifying the solve. Okay.
Yeah, I should say yes. Because whenever you're given something, you're going to.
Simplifying, you're going to do that order of operations. When you're solving, you go up.
Yes. Because we start with these huge equations. We're gonna have a couple of those, and then what we have to do is we have to narrow it down, and then at the very end, then we start moving things around. Because you may have to do both. You may have to simplify first before you solve.
I understood. I just didn't catch it at first.
Yeah, that's a great question. I'm glad you asked. I didn't even think about that, but perfect. So then there's your answer. So this is the reason we do these in this order, and we use the properties for that. Let me see. And because, okay, I do apologize for this, but because we meet once a week on Saturdays, I'm going to go pretty quick on some of these things. Not speed-wise, but I'm going to skip the more. Normally I'd do like 4 or 5 or 6 more examples of these, but I want to jump now into this type of question. What if you had that? What's different between this one and the last one we just had? There's a fraction. And how many of y'all like fractions? Liars. Yes. So, since we don't like fractions, let's look at remove the fractions. If we don't like fractions, let's get rid of them. And this is always going to, whenever you have a fraction type of equation, these 5 steps are always going to work. The first, find the LCD. What does LCD stand for? Least common denominator. So in other words, what that means is what's the smallest number all the bottom numbers fit into? In this case, we only have 1. What's the LCD? It's just itself, it's 5. 5 fits in 5. Once you find the LCD, multiply the LCD to each We're going to get rid of the fractions, right? Notice I put term in parentheses. What is a term in mathematics? What defines a term? A term, okay, look at, in this case, how many terms do we have? Well, it's a term is anything separated by a plus, minus, or equal. We have 1 term, 2 terms, we have 3 terms. Each of those are terms. Anything separated by a plus, minus, or equals. So, we have to multiply the LCD to each term. Remember, the LCD was 5. So 5 times the first term, 5 times the second term, 5 times the third term. See, and that's the bad thing about using a computer to type in when you're taking notes in a math class, because we're going to be faced with a lot of funny symbols and stuff as we go along. If you want me to, I can show you how to get the symbols in there. But yeah, we'll do it after class. So, the third step, once we multiply the LCD to each step, cancel. So, nothing can cancel here. The 5s can cancel. 5 goes into 5 once. So what we have left is instead of reduce, I usually say, instead of cancel, I'll say reduce. In other words, at this point, you get rid of all the fractions. Between this one and this one, which one looks easier to deal with? The top or the bottom? The bottom. They're exactly the same thing, they just look different. The fourth step is multiply to remove the parentheses. So 5 times 2 is 10 x. 1 times 3 is 3. 5 times 4 is 20. And then the last step, solve for x. Get that on the next page. So I have 10x plus 3 equals 20. So, to solve this, I'm solving for what? I'm solving for x. So what do I have to get rid of first? Eh.
No,
The 3. Get rid of anything plus or minus first.
oh,
So since this is a plus 3, I need the opposite of that, which is a minus 3. So we have 10x equals 20 minus 3 is 17. Now I'll get the x by itself. What do I have to get rid of now? Yeah, since this is 10 times x, the opposite is division. Divide both sides by 10. 10's cancel, so we have x equals 17 over 10. This is called an improper fraction. Why is it called an improper fraction? The top's bigger than the bottom. So we have to convert it. How many times does 10 fit into 17? With how many left over? 7. Notice the denominator always stays there. So it fits in there solid 10 one time with 7 left over. This is what's called a mixed number. A mixed number is part fraction, part integer. What's that? Well, it's okay. We know this is an improper because top's bigger than the bottom, so we convert it to a mixed number. We know it's a mixed number because it has an integer and a fraction. So we call that a mixed number. All right, do this one really quick. It may help if you want to do it the old-fashioned way, it can work also. How many times does 3 go inside 8? 2 times. 2 times 3 is 6. And if I subtract them, I get 2. This number is your integer. This number is always the denominator. And this number is your numerator, the remainder. So 3 goes in 8 twice. That's the integer. 3 is the denominator. Whatever else is down here goes on top. $37 divided by 5. So how many times is 5 going to 37? 7 times. 7 times 5 is 35, right? So 37 minus 35 is what? Oh yeah, these are different ways you can do it. So we could do it this way. This is 35. So this number is your integer. This number is your denominator. This number is your numerator. Let's convert from mixed number to improper fraction. Let me give you the formula. There is a formula for conversion from mixed number to improper fraction. So A times C, that's what it is, A times C. 4 times 5 is, add the top, 20 plus 2 is 22 over 5. How about that one? This one, we may have different answers here. What'd you get? Negative 11 over 4? Okay, there's one possible answer. Negative 13 over 4. Anybody else got something different? Everybody else got blank. Let's see. 3 times 4 is 12, plus 1 is 13 over 4, and it's negative. I know what you did. You went negative 3 times 4. So, no, this negative belongs to the whole number. Plus 1. Yeah, 3 times 4 is 12, plus 1 is 13 over 4. And put a negative in front. Signed numbers. You notice up until now, we've only been really talking about multiplication and addition. All the properties, all the order of operations. That's all we've been talking about is addition and multiplication. Why doesn't subtraction or division work? Or does it work? Do those work? Are they equal? No. I mean, 5 minus 2 does not equal 2 minus 5. Four divided by 2 does not equal 2 divided by 4. 4 divided by 2 does not equal 2 divided by 4. So why doesn't it work? Why don't those two operations work? Or do they? It fails the first property, so we can't use it at all, period. If it fails any of the properties, then we can't use it at all. But we can. by this property. The sign follows the number. The sign follows the number. In other words, subtraction doesn't exist. Subtraction doesn't exist. What exists is the addition of a negative number. These are equal. Remember, positive times negative is a what? Negative. So it's the same thing. Now, if I convert it to this way, then I have the commutative property of addition. As long as the sign follows the number. Three minus 5 is the same thing as what? Negative 5 plus 3. Using properties. Yeah, it's going to equal negative 2, yes. But we have to remember that moving around has to stay with the number in front of it. And division itself is just a whole screwed up process, so we're not going to talk about that. So that's like when we don't talk about subtraction, because it doesn't really exist. Only negative numbers exist, and that's just moving the numbers around. So, adding negative numbers. This is the rule. If the signs are the same, if the signs are the same, take the common sign and add the numbers. If the signs are the same, take the common sign and add the numbers. Five plus 3. They're both positive, so the answer is what? Positive. Positive 5 plus 3 is 8. 2 plus 7. They're both positive, so the answer is positive. 7 plus 2 is 9. Negative 4 minus 3. They're both negative, so the answer is negative. 4 plus 3 is 7. Negative 5 plus 9. Or negative 5 minus 9.
Negative 4.
Yeah, they're both negative. 9 plus 5 is 14. In subtraction, if the signs are different, if the signs are different, take the sign of the larger number and subtract bless you. Subtract the numbers. Now, when we say subtract, we always mean larger minus smaller. That's what subtract means. If you do larger minus smaller, you always have a positive answer. Nine minus 3. They're opposite signs, positive and negative. 9's bigger, so the answer is going to be what? Positive. So 9 minus 3 is 6. Negative 2 plus 8. 8's bigger, so it's positive. 8 minus 2 is 6. Negative 8 plus 3. 8's bigger than 3, so it's negative. 8 minus 3 is 5. Two minus 7. Okay. 7's bigger than 2. It's negative. 7 minus 2 is... What do y'all think? Easy. You don't need calculators to do this kind of stuff. You just, once you see these rules, how they're really working, just do them. Okay, last thing we're going to talk about, and then I'm going to kick you out. Here's the first example. Same denominators. Remember, we have numerators over denominators. So if you have the same denominator, take the common denominator and add or subtract the numerators. So, if you have a common denominator, keep the common denominator and add or subtract, whatever the operation is, the top. So we have 9 on the bottom, they're both 9s. So we have 2 plus 4, 6 over 9. Are you done? If you can simplify, always simplify. 6 is made up of 2 times 3. 9 is 3 times 3, so they both have a 3 in common. They cancel. So the answer is really 2 over 3. If we have different denominators, multiply one or both fractions to get a common denominator. Then add or subtract the numerators. multiply one or both fractions to get a common denominator. So remember, multiply top and bottom by the same number. And add or subtract. So if we had 2/3 plus 1/5. So this denominator has a 3. This one doesn't. So it needs a 3, right? We have to put it top and bottom. We have to change both top and bottom. Why? If I had 1/2 and I only changed, if I multiplied 3 to the bottom, is 1/6 the same as 2/3 or 1/3 or 1/2? No. But if I multiply the 3 on top, I would get 3/6. Are they the same? Is 1/2 the same as 3/6? Yeah, so we have to multiply. Whatever you multiply the bottom, you have to multiply the top. Now, here's another thing. What are we multiplying by? What is 3 divided by 3? 1. We're multiplying by 1. Anything times 1 is itself. You don't change it. You just change the way it looks. So, we multiply this one by 3. 3/3 is 1. Multiply by 1. This one has a 5. This one needs a 5. So what's the number on the bottom? 5 times 3 is 15. 5 times 3 is 15. On the top, 5 times 2 is 10. 1 times 3 is 3. You have a common denominator, so just worry about the top. 13/15. There's your answer. Calculators won't work too well in this course because a lot of times it doesn't want fractions. It doesn't want decimals. It wants fractions. So you gotta learn how to do this. Here's a method I like. I still use it. It sounds Mickey Mouse in elementary school, but it works. Call it the butterfly method. Multiply the two numbers across. 8 times 5 is 40. 7 times 3 is 21. 7 times 8. Everything you need is there. 40 plus 21 over 56. 61 over 56, and we can simplify it from there. So if you do it this way, there's no real thinking involved. It's just multiply across. There you have it. Even if it has, let's say, both signs are negatives. Okay, here's the only change here. You notice this is important. If you have a negative sign in front of a fraction, it belongs to the top number. The negative sign only belongs to the top. Even if you have it on the bottom, rewrite it so it belongs to the top number. The reason for that is because of this reason. If you have a common denominator, let's say we had this. So this side needs a 3 over 3. This side needs a 5 over 5. With 15 on the bottom. So we have 3. So the bottom number will always stay positive. The only number that can be negative is 10 as the numerator. Opposite signs, take a sign of the larger, subtract the numbers. So whenever you have fractions equations, the negative sign goes to the top number. Which is why in this one, we change that to a plus, put the negative on the top. So if you have a negative between there, that negative goes to the top number and it becomes a plus. Because now we can do our butterfly. Positive times negative is negative. 3 times 4 is 12. Plus. Positive times negative is negative. 5 times 1 is 5. Over 15. So we have negative 12 plus negative 5. Since they're both negative, negative 12 plus negative 5 is negative 12 plus 5 is 17. And it would convert it to mixed number. What do y'all think so far? You learned this many years ago. It's just that you forgot about it because calculators and teachers never bother re-stressing it. Now, to make sure you remember this stuff, clear your desks. Since there weren't any questions, clear your desks.